So let us start our session. So in previous session we have discussed about all the data types, reg data types and net data types we have seen. Yeah. So in this particular session we'll continue our discussion. We'll start our discussion with vectors. Okay. So up to previous. So in Verilog, vectors allows grouping of multiple bits into a single variable, and these are useful for buses, arrays, and multi-bit operations. So basically, these are vectors are nothing but group of bits, or you can say these are used for modeling buses. So can anyone tell what is the full form of this bus? Any idea? Signals. Okay, bus is nothing but bundle of signals. Okay, so when you are learning some protocols like amba protocol, ahb protocol, apb protocol, you will come across this particular term which is known as bus, which is nothing but bundle of signals, or you can say group of signals. Okay, so if you want to model that particular group of signals or bundle of signals in Verilog, you can use this vectors. Okay, for example, if there are two modules, a and b, let's say one is sender and another is receiver. Okay, let us take these two modules, and my voice is audible, right? So let us take two modules. One is, let's say, sender and another is receiver, and let's say these two are communicating with each other. We don't care about what protocol we are using. Okay, so they are exchanging some data. Okay, so let's say this particular module A, sender, is sending some data to module B, which is our receiver. Okay, let's say our module A, that is the sender, is sending 8 number of bits. Okay, so how it is going to send? It is going to use a bus, and it is going to send the total bits, 8 bits, and the width of this bus may be 32 bits or 64 bits. Okay, so using this bus, this module A and module B will be communicating with each other. Okay, it may be 82 8 bits or 32 bits or 64 bits, anything according to the requirement. We can create that particular bus. Okay, so using a vector is nothing but it's a collection of bits. Okay, so if you want to store a collection of bits, what data type you are going to use? So if you want to store let's say 8 bits, so what data type you are going to use? Whether you are going to use reg or whether you are going to use wire. If you want to store 8 bits of data,
Res data type.
yes, so we will not use wire, we are going to use reg data type for storing the data. Okay, so let's say we have a requirement to store 8 number of bits. Wait a minute. So let's say our requirement is we want to store 8 bits of data. Okay, this is our requirement. Now what data type we are going to use? Reg data type. Okay, so we are going to use this keyword reg. Now if I declare reg temp, now tell me how many bits this particular variable can store. Reg temp.
1 bit. 1 bit.
Yes, so this particular temp can store only 1 bit. Okay, it can only store 1 bit. Why? Because by default reg can store only 1 bit of data. We haven't mentioned any size. Now our requirement is to store 8 bits of data. We want to store 8 bits of data. Okay, now in this particular case we are going to use this particular concept which is known as vectors. Okay, so if we want to store a multiple bits of data, okay, if we want to store multiple bits of data into a particular variable, we are going to use the concept which is known as vectors. Okay, coming to the syntax of this vector, the syntax of this vector is data type. Data type is important, followed by the size. Okay, followed by the size and followed by the variable name or identifier name. Okay, variable name. So this is the syntax for declaring a vector. Okay, whether it may be of reg or wire. Okay, so this is the syntax for declaring a vector. Okay, the differentiation between the vector and the array is lies in the size only. Okay, so if you declare the size before the variable name, it will become a vector, and if you declare the size after the variable name, it will become an array. Okay, so be careful in this particular declaration. So if you declare a size before the variable name, it will become a vector. Whereas if you declare the size after the variable name, it will become an array. Okay, so please be careful while mentioning the size where you are mentioning. Okay, so this is the syntax for declaring a vector. Here you can see we have declared two vectors. One is of wire data type and another is of reg data type. Okay, and here wire 7 down to 0, so total 8 bits. Okay, total 8 bits we are going to drive in this particular data underscore bus. And here reg address. Okay, so total 16 bits of data we are going to store in this particular variable address. So this is how we are going to store any number of create any vector. Okay, so this particular address will look like this. Okay, which can hold total 16 bits of data. This is address. Okay, so regarding the vector, is it clear?
Some wire 7 down to 0 data bus.
Yes.
So does it hold bits, sir?
No, no,
Store.
no. That's what I emphasize. That's what I stressed on the word. We are driving the
Like
value. Okay, we are driving the
okay.
value to the data bus. We are not storing anything.
Yes, sir. Okay. I had the doubt regarding when it comes to uh, uh, giving that 7 down to 0. I thought it would hold.
No, 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 no. Okay, we are just
Only
doing.
when we want to drive 8 number of bits, we have to declare
Yes,
the size, right?
yes. In this particular case, I have
In
drawn.
case of wire also.
Yes, I have drawn two modules, right? A and B, which are
Yes, sir.
communicating each other, and they are sending data, right? So this particular bus will be modeled like this with this help of wire 7 down to 0 data bus. Okay, that we will see later. That we will see in the coding.
Okay.
Okay.
Uh,
So simple. Vector is nothing but a collection of bits. Okay. So if you want to store or if you want to drive multiple number of bits, okay, then you can use this particular concept of vector. Okay. So vector, if you want to declare the syntax, you can see the syntax data type followed by the size followed by the variable name. Okay. Size, with the help of size, you are going to declare or you are going to tell how many bits you want to store or you want to drive. Okay. That's it. And if you mention 7 down to 0, this will be your MSB and this will be your LSB. And if you mention 0 down to 7, this will be your MSB and this will be your LSB. Okay, this is indexing. Okay, generally we will prefer this type of indexing, 7 down to 0. Okay, this and all I'm not discussing because you will get confused. So we will stick on to only one type of representation, that is MSB down to LSB. MSB down to LSB. That's it. Okay. So this was about vectors. And by default, if you haven't given any size, then the default size will be equal to 1 bit. And let's say if we have reg 1 down to 0 A, then what is the size of A? Then how many bits can this particular variable can store?
2 bit.
2 bits. Okay, it can store two number of bits. I hope now it is clear, right? And remember, next comes integer. Okay, so we have in Verilog the data type which is known as integer, and by default the size of this particular integer is 32-bit signed number. Okay, so what is meant by signed number?
It holds the positive and negative.
Yes.
Positive and negative.
So using this particular integer, we can represent both positive and negative numbers. But in the case of reg, so whether it was signed or unsigned, whether it was signed or whether it was unsigned, what we have seen in the case of reg?
Unsigned.
Yes. So basically, this reg is unsigned. Okay. And what we have seen, but what if we want to store any negative number inside this particular range? So how can we store? How the compiler is going to store?
Two's complement.
Yes. So compiler is going to convert the particular number uh, into 2's complement, and it is going to store it in a range. Okay. Whereas in the case of integer, we can store both the positive numbers as well as negative numbers, because it is a signed number. Okay. And by default, the size of integer is 32 bits. Okay. By default, the size of integer is 32 bits. So if you want to store anything, let's say integer a, then what is the size of this particular variable a?
32 bit.
32 bits. So a will be equal to 32 bits. Okay. And the default value of a, any guess what is the default value of a?
Unknown.
1.
Yes. So the default value of a will be equal to unknown, since it is of integer data type. So the default value of integer data type is equal to unknown. Okay, you can note it down. So the default value of integer data type is unknown. Give me a minute. Default value of this particular integer is unknown. Okay, do remember the default value of this particular integer is unknown. And in Verilog, in system Verilog, we will discuss the two-step data types. So in Verilog, whatever we are discussing, these are all of 4-state. Okay, so these are all known as 4-state data types. So what is meant by 4-state data type? Can anyone guess?
It holds the unknown and high impedance 0, 1.
Yes. So what are meant by 4-state data types? So they can have the values of 0, 1, unknown, and high impedance. Okay. So in Verilog, all the data types which we are going to encounter, all are only 4-state data types. So they can have the values of 0, 1, x, and high impedance. So whatever we have seen, reg is a 4-state data type, wire is a 4-state data type, and integer is also a 4-state data type. Okay. Is it clear?
Sir, integer can store also store values, or no, it cannot store values.
Yeah, integer is used to store the values. Okay. So only wire cannot be used to store the values. Okay, except wire, everything like integer, real. Okay, we can store the values. Is it clear?
Yes, sir.
Now let's say if we have reg 31 down to 0, a, integer b. Now tell me, my first question is, what is the size of a and what is the size of b?
32 bits.
Okay. Now, so this a and b both are equal or they are different? So we may see the size and we may tell that both are same, since both the sizes are same. Okay, reg 31 down to 0 is nothing but integer, so both sizes are same. We cannot say like that. Okay, first one is unsigned. Okay, first type of representation is unsigned, whereas second integer is signed. Okay, do remember the difference. You cannot say both are same. No, both are not same. Okay, so integer is also used to store the values, and what is the maximum size it can store? So what is the default value? Unknown, and it is
Unknown.
a 32-bit signed number. Okay, now coming to next type, which is, and one more important point, integer is synthesizable. Okay, integer is a synthesizable construct. Integer can be synthesized. This is also important point. And tell me whether reg and wire can be synthesized.
No, sir.
Discussed in first session, right? So what is meant by synthesizing? Which is nothing but converting our code into hardware. Okay, that is nothing but synthesizable. Okay, so if there are two types of constructs in Verilog. One is synthesizable constructs, synthesizable, and another type is non-synthesizable. Okay, synthesizable in the sense which can be converted into hardware, which can be modeled into hardware, whereas non-synthesizable means which cannot be modeled into hardware. Is it clear?
Yes, sir.
Yeah. So finally, what is our requirement? We are doing Verilog. We are writing Verilog code so that we can implement on it some hardware like FPGA. Okay. So we should be careful what type of constructs we are using in our coding also. Okay. We might be tempted to use some constructs which are not synthesizable by our EDA tools. Okay. So we should be careful when we are writing the coding also. So, and coming to this reg and wire, both are synthesizable. Okay. Reg and wire both are synthesizable. These two are synthesizable, and integer is also a synthesizable construct. Will not get synthesized. Okay. So basically, this real data type is used for floating point numbers, and it is used for non-integer calculations. And this is majorly used in simulation purpose only when we are using test bench, and if we have any requirement regarding this particular, we can use this particular, and we cannot directly connect to the hardware. Okay, and this is also very important point when we are declaring the ports. About regarding this ports, we will declare in our next upcoming slides or sessions. Okay, so when we are declaring some module ports also, we cannot use this real data type. Okay, since it's not a synthesizable construct, we cannot use it in our main code, main design code, as well as in our. So this was about real data type, and the default value for this real is also unknown, as well as the size of this real data type is 64 bits. Okay, the size of this real data type is 64 bits, and the default value is unknown. And if you want to use if you want to model any floating point, you can use a keyword real. You can use a keyword real for creating a real data type. Okay, you can use real followed by the variable name, comma p. Okay, now, and it is also a signed data type. Okay, real is also a signed data type. Now, next comes the time data type. Okay, so basically this time data type is used to display the simulation time. Okay, so let's say this constructs everything I will show you. So let's say if you have initial beginning block also we will see in the BFM modeling. So for now I'm writing to show how we are going to use this time data type. Let's say if we have some time delay, hash1 is equal to 1 and hash2 b is equal to 3. Okay, and dollar display construct we will use for printing purpose. Dollar display a is equal to percentage d comma a comma, you can use here dollar time. So basically this dollar time is a system task. Okay, any variable or any keyword which is starting with this particular dollar symbol, it is a system task. You can note it down. Any keyword which is starting with dollar symbol, it is a system task, like dollar display, and you have system tasks like dollar monitor. Okay, so yes, dollar strobe. Okay, so these are all your system. Okay, these are all your system tasks. Okay, and time variable is used to display the particular time of execution or simulation time. So if you want to know at what time the particular event is happening or at what time a particular assignment is happening, okay, so you if you want to know the simulation time, you are going to use this particular time variable. Okay, you are going to use this system task which is known as dollar time. Is it clear?
Yes, sir.
Yeah.
Sir, what is actually a system task?
Yeah, system task is nothing but which is used to achieve some system tasks like are you aware about this functions and tasks concept?
No, sir.
Yeah, okay, so I will clearly explain what is meant by system task, everything, if we encounter about that. Okay, so in upcoming slides we have everything. Okay, So basically this dollar time, everything, these are all predefined system tasks which are written inside our library. So we are actually calling them. Okay, we will discuss them in detail. Okay, so here what we are doing is we are declaring two variables of which data type we are using, time data type. Okay, so we will use the keyword which is known as time for declaring two variables, and these two are of time data type. And here what we are doing, start underscore time is equal to dollar time. Okay, so here what we are doing, start underscore time is equal to dollar time, and we are waiting for 100 time units, and we are assigning end underscore time is equal to dollar time. So basically what happens is, if we use this particular system task dollar time, okay, if we use this particular system task dollar time, it will return the current time. It will return the current time. So what is the current time? What is the current time? At what time this particular execution is happening? It is happening at zero time units. Okay, it is happening at zero time units. So zero time units will be stored inside this particular start underscore time. Okay, so if we call this, if we use this dollar time, it will return the current time. Okay, it will return the current time unit, and it will store it into the particular time variable which we have declared. And after waiting for 100 time units, we are assigning this end underscore time is equal to dollar time. So what value will be stored in this particular end underscore time? 100. Okay, and if we observe carefully, I'm using the word time unit. I'm not mentioning whether it is in nanoseconds or whether it is in picoseconds or whether it is in seconds or anything. I'm using the keyword, I'm using the term time units. Okay, so if we haven't mentioned explicitly the time unit, that concept we will discuss in upcoming sessions. Okay, so how to declare this time units and what time units this particular delay is happening, everything we will discuss. Okay, still we are in a starting phase, so I'm not diving deep into this. Okay, is it clear? So here in this particular simulation or in this particular code, I haven't mentioned any time units for this particular time. So I've just mentioned hash 1000. That's it. So I don't know whether it is sorry, hash 100. I don't know whether it is 100 nanoseconds or 100 picoseconds or 100 seconds, everything. Okay. So that's why I'm using the word which is known as time units. Is it clear? No, 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 no. Hash 100 is a delay. Okay, so this also we will discuss. If you want to introduce any delay, you are going to use this hash symbol followed by the delay.
Yeah.
Okay,
But while defining the display port, there is like elapsed time is equal to percentage something theta
this is
t
a
we are
format
written, right?
specifier. This is a format specifier for displaying the time. Okay, so when we are when we are discussing about how to display something in our upcoming sessions, when we are discussing about this display statements, everything, we will see the format specifiers. Okay,
Okay, right. Fine, sir.
yeah, so don't worry about this what and all, just focus on what topic is going on. Okay, uh, so I'm taking the quotes from the advanced slides. Okay, everything we will discuss in the upcoming slides, like format specifiers, what, how to display time, how to display integer. Okay, so these are not, these are, so this was about what we have seen. So we can assign 0 1 x and z. So these are the four states we have. So nets and rich, and nets we have wire and registers. This logic is not present in Verilog. This is present in system Verilog. Okay, and vectors, which are nothing but group of bits, and integer is 32-bit signed number. Okay, everything we will see. Okay, where we are going to use reg, where we are going to use wire, where we are going to use integer. Okay, so everything we are going to see. So what is the agenda for this particular sessions are just to introduce you all the data types. That's it. Okay, the application of the data types and application of everything we will see. We will see how to write a test bench, how to write a design, how to connect with that particular design. But what I need is some time. Okay, so after discussing every construct, so we have still some more constructs. Okay, some for 2 to 3 sessions we are going to just discuss theory only. Okay, so after completing everything which is needed for this coding, then only we can start with the coding and we can do the coding for long time. Okay, so first we will discuss all the theory which is needed for coding. Okay, we will see all this and after that only we can start the coding. Okay, so until that I am not going to start the code. So after completing everything which is needed for coding, then only I'm going to start with the code. And